Okay, good morning. Welcome to
SuperMath number 28.
SuperMath28. So we worked through a very difficult example in the book about areas in a sort of a odd-shaped quadrilateral, and it involved areas of triangles. And so I just made up a similar problem. See if you can talk your way through it. So I have a quadrilateral. I don't know anything else about it, except its diagonals meet at this point in the middle E. And the area of the triangles that are formed are 18, 30, 15, and this area is x. And the question is find x.
Well, there's some common heights that pairs of triangles share.
Actually, can you switch to blue so because of those common heights will show up?
Well, this common height between 30 and 15, it sort of looks like it might be right on this line.
Yeah, bad drawing by me. Okay.
But anyway.
That's fine. It does look like I made those intersections parallel.
So I'm gonna call
perpendicular. Sorry.
I'm gonna call this base 1 and this base 2. Okay. So we know 30, which is the area of this triangle, is base 1 times, I'm just going to call this h1.
Alright.
It's h1 over 2. And 15, well, I'm just going to write this as 1/2 to make it a little easier.
Okay.
15 is b2 times h1 times 1/2. So this ratio 30 to 15 the heights cancel and the halves cancel. It's b1 over b2, which simplifies to be 2 to 1.
Okay, so we wrote down the equation for the area of this triangle and the equation for the area of that triangle. And we just took the ratio of those and we found a nice ratio for B1 divided by B2. And that ratio is?
2 to 1.
2 to 1? Or more even simply?
2.
2. Okay. Does that tell us how long B1 is?
Nope.
Nope.
It just tells us that it's twice as long as B2.
Okay.
So this is our other height for the other pair of triangles, 18 and x.
Okay.
So it looks like I'm running out of space. Where should I write it?
You can write it in the same place. We'll remember that B1 to B2 is 2. Write that ratio up high. Okay.
So 18 is 1/2 B1 times height 2. This is height 2. Since we're using a different height.
Yep.
X is B2 times height 2 times 1/2. Cancel, cancel, and I get B1 over B2 again, which is 2, which is also 18 over x. So that means x has to be 9.
Okay. So it's interesting. I draw a quadrilateral and I draw the diagonals. Once I know the 3 areas of those 3 triangles, the fourth is forced to be something. In this case it's 9. Okay. And the other, in the case example in the book, it was 16. But it's not, you can't make a quadrilateral out of 4 arbitrary triangles. It looks like once you make 3, the fourth one
is forced.
That's a pretty interesting geometric property, and it uses ratios and just the very simple 1/2 base times height formula. Pretty cool, right?
Yep.
All right. Good job this morning, huh? Good job.